Hi, this is Dave Farina, and this is my Inquiry Design Lab for ACTE 651, Module 2 for Summer 1 of 2016. In Module 2, we were asked to use the following supplies to filter water. And we classified materials based on if they were a physical, biological, or chemical filter, and we related them to earth features. So, for instance, our sand was both a physical and a biological filter because it can, in fact, filter particles as well as things that are alive, like bacteria. When pouring the water through the top and percolating down through the different layers, I decided that the biggest ones should come first, followed by the smaller ones, and the smallest last. I've actually done this experiment with my students before. It's slightly different format, so we'll see how it goes. Here's my design idea. So I've got a total of 5 cups, and I've got the top one here with dirty water and alum, the next one down with just gravel, the next one down from that with sand, the following one with carbon and coffee filters, the next one after that sand and cheesecloth, and then finally toothpicks with triangle supports at the bottom. And the hope is to get clean water at the bottom in the bowl. But the whole thing connected by these thumbtacks and then surrounded by rubber bands to hold the whole thing together. So step 1, I mixed the soil and water, and step 2, I added the coffee and oil mixtures. Step 3, I shook the whole thing vigorously and let, in step 4, it to settle out over by gravity and observed the overall turbidity, the clarity of the water. The higher the turbidity, the harder it is to see through. Next, I added an agent called alum, and then I shook it once again and let it settle. This is a picture on the right from time equals 0. And observe the water and alum mixture over time. And if you look at the very bottom, you can see some kind of stuff falling to the bottom and a layer floating to the top. I do have a little short video here if I can get it to play. If you look closely, you can actually see some things floating to the top. I'm going to play that one more time. Right here, you can watch something coming to the top. There it goes. And you can see other things at the bottom here falling down. One more time, I'll send it through. And hopefully you can see the process at work. While flocculation was occurring, I was punching holes in the bottom of my plastic cups. And there's the final product. I was a little concerned when I was doing this that the holes were not going to be big enough and that there was going to be adhesion of the water to the cups. And at the end of the process, there is the completely flocculated water. So we've got flotation and coagulation, and the denser stuff goes to the bottom and the less dense stuff goes to the top, and then you've got more clear liquid in the center. In my lab, I use calcium hydroxide to do the process along with the alum, and it seems to work a little bit better. The Dixie cups now are going to be filled with the various materials, starting with the gravel, the next one with sand on top of this cheesecloth, which then I've stacked. Then the next one here I also have prepped with cheesecloth and sand. And then over on the side here, it's actually beneath my head. See if I can move my face here for us. You can see the charcoal and you can see the coffee filter that it's going to go in. Next, I stacked the whole thing together and I realized that my original design was not as good as I would have liked. Unfortunately, the top cup was pretty much useless and these side thumbtacks were not staying on and holding together like I thought they would. So I made the executive decision and pulled them. Um, Finally, the toothpick tower seemed to be not working. So if you look at the very bottom of my cups here, you'll see that there's holes in the bottom of the cup on the sides to allow the water to leak out. I then started to fill, and larger particles were trapped as planned at the very top. On the left here of step 14, you can see that the water level is now dropped and the material is sticking up at the top. And in step 15, some clean water, it's not too clean, is making its way out. And if you look closely, you can actually see some of the carbon is coming out as well. And I kind of thought this was going to happen. It happens in my lab in the past, and it's hard to get rid of. If anybody has any ideas, I'd be interested in hearing about them. So collected the data. The water came out the other end rather dirty, but definitely lowered turbidity. Sorry about that. So it's similar to Earth's filtering process, as I said earlier, because of the different materials it's passing through. I think I could improve this by making the filter larger. This small design makes it very difficult. In the real world, you need at least a foot for it to act as a filter. Additional materials that I could use, calcium hydroxide would be one. There it is, slate lime, and could cause a chemical flocculation process. I don't think this would be safe enough to drink. And finally, engineers would probably go through this process again. And if I were to do this all over again, what I would probably do is to end the process with the alum rather than start it with the alum. Thank you very much.